0.080. Today I'm going to be talking about a Vickers test that is performed on a Vespa piston. So, what does the Vickers test measures? The Vickers test measures hardness, which tells us how resistant a material is to permanent indentation. In simple terms, we press a diamond pyramid into the surface and see how much the material deforms. Hardness gives insights into the material's strength, wear resistance, scratch resistance, and its ability to withstand surface loading or damage. This test also helps us evaluate heat treatment results, whether the material structure is uniform, case hardening depth, and different microstructure phases such as ferrite, pearlite, and martenite. Moving on to the test equipment and load application. The indenter used is a diamond square base pyramid with a 136 angle between opposite faces. A small load is applied around 0.8 kilogram or kilogram force for my sample, and a piston dashboard system controls how smoothly the load is applied and ensures the loading time is about 10 seconds. After unloading, we measure the two diagonals of the square indentation, the first diameter being D1 and the second being D2. The microscope gives accurate diagonal lengths. We then compute the average diagonal, since the indentation should ideally form a symmetrical square. So to get the average diagonal, we addition the first diameter and second diameter, D1 and D2, and then we divide it by 2. The Vickers hardness number, or HV, is calculated using the applied load, the average indentation diagonal, and a constant being 1.8544 used in the formula. The final result is expressed as HV, often treated as a unitless value even though it's derived from kgf per millimeter squared. Now moving on to gathering the data, what we need to do first is set the measurement using image J. In image J, you set the scale first so that the pixel length matches the real millimeters. So the pixel length in the picture that we had taken from the microscope matches the real millimeters. We measure each indentation by dragging a line across. So for instance, we can see here that the two very long lines equals to 0.1 millimeters, indicating that the much smaller ones is 0.01 in actual distance in millimeters, and the one and then to the middle point is 0.5. And that's how we get the actual distance in image J. Now moving on to calculating the actual Vespa piston and the indentation that the diamond had left. We first measure each indentation by dragging a line across the diagonal. So for that, we're going to go into the straight tool, then we're going to drag along the diameter twice. As you can see what I did there, and then we're going to go Control M, and that is just to measure the actual length. So on the very right side, at the top left, you can see the length. The first one being 0.167 and the second being 0.168. For each indentation, we record two diagonals, and then we calculate their average and then get the HV using online calculators. So for my test or my sample, I did 3 indentation. So A and B are the indentation for number 2 of the sample, and C and D are the third indentation. On the same, so A and B are the same indentation, just calculating it. A is D1, B is D2, and C is D1, and D is D2. A and B is for number 2, and C and D is for number 3. The previous one I showed is number 1. Now 3 indentations were taken. Each indentation's diagonals were measured with image J. The HV values were then calculated using Word and England calculator, Omni calculator, and Toolen calculator. So here we addition. So now we have all the results for all 6 diagonals, right? And then what I did was I just addition each segment. So the first indentation, second indentation, and third indentation, leaving it with just 3 diagonals. And then I divided by 2 to get the average of it all. And then at the end, I just added all 3 of them and just to get the average of each one. So for the first one, I used a Vickers hardness number calculator from Gordon, England. This is the result for the first indentation, with the force being 0.8 kgf, and then the mean diagonal is 0.167, making the HV 53.19. And this is for the second one. The force is the same for all of it. It just differentiates in the diagonal length. So for this one, it's 0.18, making the HV 45.7. And then the third one, with the mean diagonal of 156, the HV is 60.9. Now, I tried inputting the results in Omni Calculator. So this is for the first one, with the Vickers hardness being 53.19 or 53.2. This one is just a bit different from the Gordon England because it shows the surface area hardness and the tensile strength. This is for the second one, 45.79. And this is for the third one, 60.96 or 61, if we're going to round up. Now this is the third one, tooled on calculator. This is just the same, with the Vickers numbers being 52.87 or 53. What's different from this calculator is it asks you for the first diagonal and second diagonal, whereas the first two just ask for the mean diagonal length. This one also gets an average diagonal and the hardness range of the first one being 0.63 HV. Now this is the mean of all of three indentations of the Vickers test. So the force is still the same, 0.8, but the mean diagonal of all three combined is 0.1678, making the HV average of 52.6. And then we input the same into tool done, all three indentations, getting the results of 52.71. And then lastly, Omni Calculator also resulted the same, which is 52.67 or 52.7. All three calculators gave consistent results, allowing a final mean hardness value. Now moving on, we're going to go into Vickers test that we tested on a boring Supra. So it's same procedures. First we scale set at image J, which is 1,000 times magnification, and then we're going to go into the diagonal measurements and then HV calculations. So for the boring Supra, the first diagonal is 0.112 and the second is 0.104. This is in 100 times magnification, so it's different from the Vespa piston. The results were again validated using 3 different online hardness calculators. So for this Gordon England, we got the HV of 127.18. Omni Calculator also resulted the same in 127. And Toolon also resulted the same HV of 127. The Vickers test is an accurate and versatile method for both soft and hard materials. It helps check material uniformity and ensures manufacturing processes like heat treatment or machining are correct. Small indentation size makes it suitable for thin components such as piston coatings or surface treated layers. That is all that I have to offer. Thank you so much for watching, and I deeply apologize if I made any mistake. Thank you.